All right, this video is a summary video for Monday, September 28th. Starting with announcements, a reminder that there is office hours tomorrow from 2 to 3. The link is in Schoology. If you go here, scrolling down either period 1 or 5, link to office hours, just click it and then it'll automatically get you in. Right. And then a reminder that there was a quiz last Friday and your quiz grade will be released on Thursday. If you haven't taken this quiz or were absent this day, please email me or let me know in Zoom class in the chats, and then I will release you the quiz with the time periods to take it. So our lesson for today is to learn about how all of the elements on the periodic table were formed, right, and how new elements are made. And the lessons related to that in terms of chemistry is fusion and isotopes. Okay. So I want you to notice these 3 panels. And in these 3 panels, I have 3 different elements. The first element, hydrogen, then helium, then lithium. Right? You might notice that helium and lithium look kind of weird as elements, and that's because these are not neutral atoms. Right? We'll learn about these later on, but don't worry about them for now. Just understand that they're a little weird because I want you to notice a very specific pattern, right? Protons are the red circles, neutrons are the gray circles, electrons are the blue circles. So I want you to notice right now what's different about this element from the second element to this third element. Feel free to pause the video if you need to, and let me know what you notice is different about these elements. Okay, so hopefully you notice that here I have 1 proton, here I have 2 protons, and here I have 3 protons. So the thing that makes each element different from each other is the total number of protons that they have, right? And they're organized in the periodic table. So if I have 1 proton, this top number will show up as 1. So 1 proton, 1 element. 2 protons, element number 2, helium. 3 protons, element number 3, helium. 4 protons, element number 4, beryllium, so on and so forth. So the thing that makes each element different is the number of protons that it has, right? Then we watched this video on where new elements come from. Basically, they come from stars crashing into each other super, super fast. Right, so I'm just going to play part of it to certain parts, like right here. Boom. Okay, so new elements come from our sun. Our sun is an example of a star. And basically, what's happening is in the sun right now, there are 2 types or different types of hydrogen atoms, and they're whizzing around super, super fast, and they're going to crash into each other. So when they crash into each other, they move so fast that they make one larger element. Right? So basically, all of the elements made in the periodic table that you can see are all made from stars. Right? So if I have 2 hydrogen atoms crashing into each other at super fast speed, right? Can you guess what element they would make? Let me give you a hint first. Right? So here I have 1 proton and 1 proton. They're going to come together, crashing into each other. How many protons will I end up with? You might have guessed, well, if they're just crashing into each other, I'm going to end up with 2 protons, right? How many electrons do I have? Well, not that many. I don't have any neutrons. If I did have a neutron, it would look something like this, right? But since they aren't drawn, I don't have any, so I would have 0 neutrons. Out here are my electrons. There's 1 each, so if these two crash together, I'm going to end up with 2 electrons. So in the stars, right, we have a whole bunch of hydrogen atoms that are just crashing into each other, and they're making helium. Eventually, when our star or our sun runs out of hydrogen, right, they'll be crashing helium atoms together, and so on and so forth, right? So that's how we make all of the elements in the periodic table. Okay. So this is also in your Nearpod notes, right? So fusion is the combining of nuclei to form bigger or heavier nucleus or bigger or heavier new elements, right? Know that on the side, it creates a whole bunch of energy, and that's how new elements are formed, right? So on this slide, in the next series of slides, we're going to figure out whether you can figure out what new element is made, right? So something that will help you out with these is if you go to ptable.com. So in your web browser, just go ahead and type in ptable.com. You don't have to actually type in this whole thing, just ptable.com, and you'll get to the same place. Right. Okay. So I want you to think of this row, this top row, as one equation, just like we did in the previous slides. So here I have 2 protons is what my top number means, plus 3 protons. How many protons will I get? Well, I will end up with 5 protons because 2 plus 3 is 5, right? So if I want to figure out what element this is, if I combine helium and lithium, well, then I need to check ptable.com. I'm going to look for elements number 5. Right, so elements number 5, the top numbers go in order. So 1, 2, 3, 4, 5. So elements number 5 is going to be boron B. So now I know back in the actual problem that this is element B, boron, because it has 5 protons when these two crash together. How much will this boron weigh? Well, to figure that out, I would just need to figure out the mass. So that's my bottom number of these elements. Toot toot. So 4 plus 7, what does that equal? 4 plus 7 is 11. So 11 will be my mass. Right. So that's how you figure out how new elements are created. So feel free to try these other slides on your own, but also know that I go over them in the Nearpod lessons as well. Right. Okay. So for these two, what's different about these two types of hydrogen? So at this point, go ahead and see what the top number and bottom number of each of these would be, and then see if you can figure out what's different about each of these. Okay, so adding the top row, 1 plus 1 equals 2. 1 plus 1 for this one still equals 2. If I look at the mass, 1 plus 1 equals 2, but then down here, 1 plus 2 equals 3. So sometimes you can have the same type of helium, we should say helium. I could have the same elements. They're both helium because they both have 2 protons, right? But their mass is different. So notice here that their bottom number or their mass number is different, right? So the reason why mass can sometimes be different is if you're having two different elements crashing into each other in the star or the sun, things can get messy, and you can use different elements to make the same type of element or the same type of helium, right? So therefore, you might end up with things that have slightly different masses. So elements that are the same but have a different mass are known as isotopes, right? Those are called isotopes. So let's talk about that next. Right. So anytime you have an isotope, they are the same elements with a different mass. Right. So these are the same elements, same number of protons then, but different number of neutrons. Okay. So lesson 3.6, I'm going to focus on this part on isotopes, right? Because there's two ways of writing specific isotopes, and we need to be able to figure out how many protons, neutrons, and electrons are on there. And then lesson 3.5 will focus on something like this, fusion. So as per usual, after class, we had some time to work on our Nearpod lessons. So to find that, week 7, Monday class materials, clicking on homework, right? Nearpod lessons are the same. So if you open up, right, fusion is the title of your notes. These are the things you need to be able to do. This is your Nearpod lesson. So if you click onto here, it'll ask you for a code. The code is listed right below. If you don't recall how to set up your notebook, it's linked here. And then if Nearpod is lagging or not working, you can get to the same slides by copying and pasting this link down here. So let's say Nearpod is not working. I paste the slides. Here are my slides. It's just not on Nearpod. The steps are the same. And you'll notice that the video won't play, but in the slide before, I also linked the YouTube video. So you can watch the summaries there. Here are your notes from the video that will play, right, all the way down to the end. Right. So lesson 3.6 is pretty much the same thing, right? It's just in a different color to let you know that this is a different lesson. Once you're done with that, step 3, it says to make a copy of this document and complete as homework, and then upload this document to submit. If you're struggling with how to upload the document to submit, feel free to share the document with me. So here, if you click on this, you're going to go to File, Make a Copy, and then delete the copy of, and then you can type in your name, Quan, period 1 or period 5 or whatever period you're in, medchem, and click OK. So this version you should be able to type in, right? So because this one is on isotopes, the video lesson you want to look at is the one titled Isotopes, and that should help you out with these questions, right? And in fact, I think I do problem number 1 and problem number 2 in your homework in the video as well, right? Okay, so once you're done with this, you can go ahead and upload it on Schoology. If you don't know how to do that, go ahead and click share and then type in my email address. So my email is going to be QQ, so 2 Q's, UAN at SLUSD.us. then click done. Right. Okay. So that was mainly it for Monday, September 28th.